So translation of axes. So we no longer looking at the graph center of the origin. It's going to be centered somewhere else. Again, in our book, the book we're using, which is Basic Technical Mathematics by Washington, page 595, have a list. It says, we know what the circle is. We covered that before, but we never looked at parabolas where the center is not at the origin, or an ellipse, or a hyperbola. And I always tell the people who was watching the video online there, if you freeze the camera right now, I'll keep moving my hand, take your phone, take a picture of it. Then you can email it to yourself and print it. So that's one way to get a copy of that picture. Because I always get requests, can you somehow put this on a Google Drive so we get to share with everyone else can see it? We can't here. In my school they will go, no way. But just freeze the picture, freeze the video, and just take a picture of that with your phone and print it. Or just write it down. So here's what we know. Remember what the parabola looks like. Parabola is only one side. So I'll write them down here. That's y minus k squared equals 4p x minus h. Right next to it, it says axes parallel to x-axis. That's for a parabola here. Maybe, I don't have a red color. So let's talk about parabola with vertex at h comma k. Or it could have x minus h squared equals 4p y minus k, and this is axes parallel to y-axis. I'll give us some examples shortly. That's for parabola. Ellipse here. Vertex at h comma k. This will be what? Y minus k squared over a squared plus x minus h squared. Remember, for ellipse, a is always the longer side, right? A is always the longer side. So the longer side is which side here? If I write it like this, the major axis, the longer side is going to be which side? The y-axis, right? So the major axis here is y-axis. It's actually not the y-axis, is parallel to, I should say, because the center is not going to be a 0, 0 anymore. Parallel to. And if it was x, would be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. The major axes here will be parallel to what? Parallel to x. Plain English, the graph for this one will look like this. The graph for this will look like that. Now, the next one, hyperbola there. center at h comma k. If the x is positive, x minus h over a squared, minus, hyperbola is always a minus, there's no plus in a hyperbola, minus y minus k over b squared equal to 1. The transverse axis, that's twice a, is going to be along which axis? X-axis. In the x direction. And if it's reverse, if it's y minus k squared over a squared minus x minus h squared over b squared is equal to 1, the transverse axis will be which way? Yep. Again, what do I mean? My graph, they're not centered at the origin here, could be centered anywhere. So the graph for this along the x-axis, so this will be like this. And when it's y is positive, the graph is going to be which way? Up and down, right? And again, the center could be anywhere. It'll be up and down. For this one, the graph will be upward or downward here. And for this, the graph will be left or right. You know? So that's how you know which one is it. Now take some examples and go through them. So all the ones we did on these, the center was at the origin. But now we're changing the center. So you get three things to look at. The first one's the parabola. The second one is the ellipse. And the last one is the hyperbola. Three different things. The circle, we covered that already. So I don't have to deal with it. So let me take an example and go through it and see what will happen. Let me begin with this one. Y minus 4 squared equals 8 times x minus 2. Notice only one of them is squared. Do you notice that? Only one is squared. If it's only one of them squared, that's a parabola. Not both squared. So that looks like which format? Let me get my sheet back. Which one's the square? Is it y or x? Y. So it's either going to be left or it's going to be right. It's going to be in the across the x-axis, like this, or like that. Depends on p. So let me try to compare it to the standard form. The standard form is what? I have a red one here I can use. Here's my red one. There we go. This might work with both these. So try to make it compare it to the standard form, which is y minus k squared equals 4p x minus h. Just when you compare to that, you already know where the center is, right? H comma k. So center where? What is h here? Plus 2. And what's k? 4. That's where your center is. 2 comma 4. So I know now my graph 2 comma 4. There's 2. And let me go 4 up there. Right here. That's where the center is going to be. The vertex, when I say center, the vertex of that point. So my graph is either going to be to the right like this or to the left going through that point. Is it to the right or to the left? That's where P comes in. 4P is equal to what? 8. P will have to be what? 2. Now what I want to do at this point, I'm going to pretend I don't see these axes. Make a new set of axes going through that point. Make a new set of, make them with an eraser because I'm going to erase them shortly. I'm going to pretend that's my x and y axes. Can you see them on the screen? Light. And graph this just like if it was y squared equals 8x. If you were to graph that on this one, we know that's the center, so the vertex, we found where that is. Now that's going to be parabola. P is 2, it's opening to the right. So it's going to look like this. So the focal point is going to be 2 units up. 1, 2, because P is 2. So let's go 2 to the right. That's right here. That's your focal point. Your directrix is going to be 2 units back, which is right here. Same distance from the vertex to the focal point is the same from the vertex to the directrix. So directrix for this one is going to be right there. If you remember, we said the easiest way to graph it, measure the distance from here to there, which is how many units? 4. Let's go up 4 units. And down 4. And that'll give me 2 points on the graph. So my graph is going to look like this. That's what the graph. So if you want to take your eraser now and erase the pencil mark here, you can. And if you leave it, it's not a big deal. But if you erase it now, that's where your graph is.
Why did we go up and down 2 again?
Up and down 4, you mean? Because what the directrix tells you, if you pick a point, yep, from here to there. If you pick a point on the graph, that's how you know how far. If you measure that distance, and you measure directly to the directrix, which is right here, has to be the same. So that's why you go 4 up, because I know the distance, when you go up and down here, that distance from here to there is going to be twice that. That's why I go up 2 units. Now, what's the focal point if you want to find that focal point? We know that distance 2 units to the right. We know where the vertex is. Where's the vertex? 2 comma 4. Right? We know this point is 2 units to the right of that. That will make it what? 4 comma 4. Directrix right here. That's what? X equals to 0. So we know where the vertex, we know where the focal point, we know where the directrix, we know everything about that graph. I'll try another one. Let's take this one. x minus 3 squared divided by 25 plus y plus 2 squared divided by 9 is equal to 1. Now notice you have equal to 1 at the end. Well, if it's equal to 1, it's one of two things: ellipse or hyperbola. Why is there ellipse there? Both signs are plus. It's ellipse. To be a hyperbola, this will have to be what? Minus. So this is my x and y axis. Here we go. Now, A is what? 25? It's along the x-axis. So this is going to be which way? It's going to be this way. The ellipse that looks like that. Let's look and see which one of these equations for that. Well, I have it here. It's right here. X minus h squared over a squared plus y minus k squared over b squared equals to 1. So let me write that form there. Let's look at them. Do we know where the center is, h and k? Where? 3 and negative 2. So the center of the graph at 3 and negative 2. Let's find out where that point is. Let's go 3 to the right and 2 down. 3 to the right. Right here. And let's go 2 down. That's where the center of the ellipse is going to be. 3 comma negative 2. Now let's put a new fake axis here. Again, I use my pencil. Thin mark so I can erase it after. Another one, thin mark. I don't have to erase, I can even leave it there. But that's going to be like my new fake axis. I got an ellipse here. I know it's going to cross the x-axis, right? So it's going to be crossing these two lines. What is a squared equal to? 25, which means a equals plus or minus 5. Let's go 5 to the right. And that's here. And let's go 5 to the left. And that's here. So when you go 5 to the right, that's your vertex. What is the coordinates for that one? Let's add 5 to the x value. Is that 8 and negative 2? Let's subtract 5 from this. That's what? Negative 2 and negative 2. Let's look at up and down, how high that ellipse is going to go. We said b squared is equal to what? 9. b equals plus or minus 3. Let's go up 3 units and down 3 units. This is 3 and 3. So you're going up 3. The coordinates for this point then is going to be what? You're going up 3 units.
3, 1.
3, 1, yes. And this one what?
3, negative 5.
Yep. And there's your graph now. If I can connect these with nice smooth line curve here, I'll be in good shape. That's the ellipse. We got everything about it. You want to find the focal point for it too? It should be 1 here. And it should be 1 here somewhere. I don't know, it could be here. We'll find out how far first. Well, to find the focal point, how far from this we do c squared equals what? A squared minus b squared for an ellipse, right? What's a here? 25 minus 9. Is that 16? C equals plus or minus 4. Let's go 4 to the right. That will make it what? 7 comma negative 2. And let's go 4 to the left, and I'll put it what? Right here? Negative 1 comma negative 2. Again, you want to erase the fake axes? Go ahead. You want to leave them? That's fine too. So once we figure out really what the graph is, what this does just tells me where to put the new axes. Let me try another one. Let's try another one. Maybe I'll put a twist in it. 2 times x minus 1 squared minus y plus 2 squared equals 2. I see a minus. They're both squared. I see a minus. That tells me the graph is what? Hyperbola. Yep. First, to be hyperbola, you want that to be a 1. So what are we going to do? Divide everything, not factor, but divide by 2. So I will have x minus 1 squared divided by really 1, because there's nothing to divide by, so put 1, minus y plus 2 squared divided by what? 2 is equal to 1. Which axis is going to cross, the x or the y axis? X axis. It's going to look like this. Why? Because x is the positive, y is the negative. My ears are ringing. Somebody's talking about me. Yeah, probably left.
Bad.
Is that bad?
Yeah.
Uh-oh. Bastard, stop talking about me. I never heard that. So left is bad, right is good?
Yeah.
I'll kill him. Maybe that's why they're talking bad about me.
Well, you just recorded yourself saying that.
Oh, yeah, I'm in trouble. Now I'm going to jail. I know that. There we go. So since it's left and right, it's going to match this one. X minus h squared over a squared minus y minus k squared over b squared. So I was just thinking about, you said the left ear is bad. What about if you're deaf in the right ear? Then boy, you're in trouble. All you hear is the bad stuff about you. So let's see. Where's the center is going to be located at?
1, negative 2.
1 comma negative 2. So again, let's move our center to 1 comma negative 2. Here's 1. And down 2. That's where the center is going to be. 1 comma negative 2. The new center. Again, my fake axis right here now. Now I try to make it really thin so I don't have to erase it. I don't know if you can see it on the screen even. Barely. That becomes my new x-axis, my new y-axis. I pretend they're the ones. So what's a squared equal to?
1.
A equals to
1.
plus or minus 1. So go one to the right and one to the left and put a mark there. It's going to cross the x-axis, we said. It's supposed to be here and here, right on the line. Now, b squared is equal to what? 2. b equals plus or minus the square root of 2. That's 1.4 roughly. That's right here. 1.4 right here. So let's make our fake box here. There's my box. Right? So let's make it go diagonal through both of these. There's my box. Here we go, diagonal line. That's one asymptote. That's the other one. So there's your point. That's the vertex. There's another vertex here. What is that vertex, the coordinate for it? 2 comma what? Negative 2. And this vertex is going to be what? 0 comma negative 2.
So that's the same concept, right? You add or subtract?
Yes, same thing as before. So now, my graph should look like what? We said it's going to cross the x-axis. So it's asymptote to this one. Oh. That's what the graph is going to look like. Notice where the center is. Notice it's not center 0, 0. It's center 1 comma negative 2. You want to find the focal point? There's a focal point here. There's a focal point here. To find the focal point, we say c squared equals what? A squared plus b squared. C squared equals 3. C equals plus or minus the square root of 3. When we say plus or minus the square root of 3, that's from the center, from this point. I'll wait till you finish writing. So it's plus or minus the square root of 3 from this one. So let's add the square root of 3 to that point in the x direction. So this will be what? 1 plus the square root of 3. And the y value is what? Negative 2. In this direction, you're going to subtract from it the square root of 3. So it's 1 minus the square root of 3. And the y value is what? Negative 2. There's my 2 focal points. What is my transverse axis? That's twice A, remember that? A is what here? 1, twice that is 2. That's the distance from here to there, it's 2 units. What is my conjugate axis? That's twice B. That's up and down. B is what? It's the square root of 2. Twice that, 2 times the square root of 2. So the conjugate axis, the distance from this dotted line to that dotted line. From this to that. The transverse from this one to that one. That's your transverse axis. So we got everything about them. So that's all we're doing really. We're just changing the center So again, what I did with all these problems, I found where the center is, put a new fake axis there. Then I go, okay, I don't see that minus h and k. I pretend they're not even there. I go, a squared equals 61. A is this. Go from there, plus or minus. B squared is 2. B equals this. So go up and down that value and make my box. Make sense? That's what I did with every one of them. I'll stop here.